Hello there. In this video, we will be doing Exam 1, page 3, section 1. We will now begin. Use the provided graphs of f of x and g of x from page 2 to find the value of each of the following. If a value does not exist, write does not exist and explain why. And here are our graphs for both y equals f of x and y equals g of x. Limit of x approaching 2 of f of x. Well, we will go to our graph for f of x, and as we can see, at x equals 2, y equals 3, and y is also 3 for both sides of at x equals 2. And so our answer will be limit of x approaching 2 of f of x equals 3. For our next question, it is limit of x approaching 9 of f of x. So we will go to f of x, and as we can see, our x at 9 is different from both sides. So from the left side, when x is approaching 9, it's going to negative infinity, whilst when x is approaching 9 from the right side, it is going to positive infinity. And so we shall write limit of x approaching 9 of f of x equals dne, because limit of x approaching 9 from the left of f of x equals negative infinity does not equal limit of x approaching 9 from the right of f of x equals positive infinity. Sorry that it ran out of space, but yes. Our next question will be limit of x approaching 5 of f of x. So, as we can see, our graph is different at x equals 5. From the left side, our graph equals positive 3, whilst on the right side, our graph equals negative 1/4. And so, just like with the previous one, limit of x approaching 5 of f of x does not exist because limit of x approaching 5 from the negative side, from the left side of f of x equals, let's double check, the left, it equals positive 3. Does not equal limit of x approaching 5 from the right side of f of x equals negative 1/4. And that is our answer for this question. Okay, for this question, we are looking at limit of x approaching negative 10 of g of x. So we'll go to our graph, and we can see right here that whilst our graph is defined at negative 10x and that it does have a graph coming from the right side, there is no graph from the left, and because of that there is no limit, because in order for there to be a limit, the graph must be approaching from both sides. And so our answer will be limit of x approaching negative 10 of g of x equals d and e, because limit of x approaching negative 10 from the left of g of x does not exist. There we go. Now for this question, it's limit of x approaching negative 6 from of g of x. So once again, go to g of x, and at negative 6, we can see that whilst our point isn't defined at x equals negative 6, we do have a graph coming from the left and the right of x equals negative 6, and they both approach the same value at 3. And so, because of that, our answer will be limit of x approaching negative 6 of, that's an ugly 6, let me rewrite that. Let me write that again. Yeah, that's good. Of g of x equals 3. Alright, for this next question, it is limit of x approaching 10 from the left side of f of x. So we will go to f of x, and we can see that the limit does not exist for f of x limit of x approaching 10 of f of x. However, this question is specifically only asking for the left part of the limit. And so, because of that, we can see that the left side of the graph is approaching the value of 1. And so, we could put that our limit of x approaching 10 from the left of f of x equals 1. Let me just double check, and yes, that is our answer. For this one, limit of x approaching 0 of g of x, we could see that whilst we do have a point defined at x equals 0, which is negative 5, that is not where our limit is, as it's not connected to our graph, and thus this is a discontinuity. So as we can see, our graph is approaching negative 4 from both sides of the graph, and so our limit of x approaching 0 of g of x equals negative 4. Alright, now for these questions will take a little bit longer, as we can see from this one that says limit of x approaching negative 2 from the left of f of x plus g of x. Now, we will have to take some rules for how limits work, because This by itself will be quite difficult to do, but one of the rules of limits is that if it's in this format, is that you could distribute the limits. And so we're going to rewrite this question as limit of x approaching -2 from the left of f of x plus limit of x approaching -2 from the left of g of x. And so we will go to our graphs. So limit of x approaching -2 from the left for f of x equals -2. And so, in order to make this a bit easier, we're going to put this as an equals and put -2 for our f of x here. And for our g of x, we're going to go to the graph. And from the left side of our limit at x is approaching -2, it is 3. So we're going to put plus 3. And so our limit of x approaching -2 from the left is going to equal to 1. And we shall apply this same rule for our next question, which is limit of x approaching -2 from the right side of f of x plus g of x. So we will rewrite this equation as limit of x approaching -2 from the right of f of x plus limit of x approaching -2 from the right of g of x. And that will equal, let us see our graphs first, that will equal 3 plus g -2. And so our answer will equal 1. Alright, our next question will be a bit of a trick question. Our question will be limit of x approaching -2 of f of x and g of x. Now, this will be a bit difficult because, as you can see, our graphs from both sides of f of x and g of x are not equal to each other. However, in this case, we actually do have our answer based on the previous two questions, because our previous questions were limit of x approaching -2 from the left and limit of x approaching -2 from the right. And so, because both our answers are the same, both of them being 1, that will be our answer for this question, because we already took the limit from both sides. And because the limit from the left and limit of right for this equation are the same, our answer is going to be limit of x approaching -2 of f of x plus g of x equals 1. Now, this next question is a bit of a long one, so I'll zoom in so I can write a bit smaller so we have a bit more space. So in this equation, it's going to be limit of x approaching -8 of 2x plus f of x times g of x. Now for this 2x part, it's the same as the rest, applying the limit to the function, that's gonna be our first rule. Limit of x approaching 8 of 2x plus limit of x approaching 8 of f of x times limit of x approaching negative 8 of g of x. Now, we have a bit of a problem as we have a constant right here in our equation. However, there's another rule of limits where if you have a constant inside your limit, what you can do instead is move the constant outside of your equation. So we're gonna do a little bit of a change and change this to and move it right here in the back. So our equation will be 2 times limit of x approaching negative 8 of x plus limit of x approaching negative 8 of f of x times limit of x approaching negative 8 of g of x. And so we will now find our values. We'll set up an equal sign right here. And the rule for limits for f of x applying to f of x is that we just apply what the point at negative 8 is for x. So, and since our point is negative 8, our first part will be 2 times negative 8. That is as simple as that. You just need to plug in what x is approaching to at this value for this part of the equation. The other two will do as we did before. We will look at our graph and see what the limit equals at that point. So let us see. Limit of x approaching negative 8. Now as we can see, both sides are approaching to 4 at this part of the equation. So we could put a plus 4 times, we will see our g of x, and that seems to be negative 1 times negative 1. And that will equal to negative 20 once everything is added together. Alright, so now for our next question, it is limit of x approaching negative 6 of g of x of g of f of x. So, we will, the rules for distributing our limit is the same as the one for our previous question. So, we will rewrite this question as g of limit of x approaching negative 6 of f of x. Let me rewrite that. And so we will go to see what f of x approaches at negative 6. So our limit does, sorry, that was the previous one. So our limit does exist at negative 6, and it seems to be approaching negative 4. So we will rewrite this as g of negative 4. And at g of negative 4, our answer seems to be positive 5. And now for this bonus question, limit of x approaching 4 of g of x. Now, we will rewrite this question as we did for the previous one. we'll rewrite it as g of limit of x approaching 4 of g of x. And we'll see what what limit of x approaching 4 for g of x is. Sorry, just double checking. Now, our value seems to be 0 for this. So we'll write it as g of 0 equal. Now, this part is a bit of a trick question because this 0 isn't technically 0. This number is approaching 0. So whilst our graph does have a g of 0, our answer will not be -5. It will instead be -4, as our number isn't approaching isn't 0. It is simply approaching 0. And so our answer for this question will be -4. And that is all for exam 1, page 3, section 1 of this video. I thank you all for watching this, and that'll be all.